down there. Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to the Natural Sciences lesson. My name is Tuwegile Tebe, and this program is proudly brought to you by the Houghton Department of Education. Our knowledge area this week is energy and change. Our knowledge area this term is what? Energy and change. And our topic is visible light. But today we're going to do seeing light and refraction of light under the topic visible light. Let's go to our objectives and check what we have. Remember, we need to achieve something by the end of the lesson. Right, that is our objective. Objective number 1 says, describe how the eye receives light energy and how this is converted to an electric pulse which travels to the brain where they are interpreted. And we're also going to state how light is refracted by transparent substances. And then we're also going to describe the action of prism and lens on a light. Okay, and we get all this from the CAPS document, page 51. Let's check pre-knowledge. What is pre-knowledge? Remember, this is the prior knowledge that we already have. This is what we have done in the past. Remember when you're in grade 7, you did the transfer of energy where you focused on solar energy. And then in grade 8, what have we done now? We also did radiation of light and spectrum of visible light. Right. Then let's go to our baseline activity. Remember, the baseline activity is what we've learned in the past. We're just reminding ourselves. So I want each and every one to write down the answers. Then after writing down the answers, you are going to send us on 079 578 2908. That's our WhatsApp number. All right, let's check the questions together. What is the normal? 2. What are the incident ray and the reflected ray? Then question number 3. Draw a diagram of reflection of light showing the incident ray and reflective ray, including the normal. I'll give you 4 minutes to write the baseline activity. Let's start writing. We are all done grade 8 writing the baseline activity. Let's check our answers. What did you write? But before we start marking, please just take a photo and send us what you have written on 079 578 2908. That's our WhatsApp number. All right. Question number 1 says, what is a normal? Then, as you are answering, you know that a normal is an imaginary line, right? We've got an incident ray, we've got a reflected ray. The incident ray is the one that is coming in. Then the reflective ray is the one that is going out. Then we've got a normal. That's a what? That is an imaginary line. The normal is a line that is drawn at right angles to the surface of an object. Right. It is drawn at a right angle. Let's say this is a surface. And then this will be our normal. It is at a right angle. This is a right angle. For example, on our diagram then, let's say this is a surface. And then this is the normal. All right. This is a right angle. Okay. It's a right angle. This is a normal. All right. Do you understand? Good. Then let's go to question number 2. An incident ray is the light ray that strikes the surface of an object. This is the incident ray. It is an incoming ray. It's incoming to the surface. All right. And then the reflected ray is the ray that is reflected from the reflective surface. All right. We said the normal is the imaginary line that is drawn at a right angle to the surface. And then an incident ray is an incoming light that strikes the surface of an object. And then the reflective ray is an outgoing ray. This is the light that is coming into our eyes so that we see different colors. Let's say if the surface is blue, the incident ray will strike the blue surface, and then the reflective ray is the light that is coming to our eyes that makes us see color. Then the reflected ray will be blue. Therefore, we will see color blue, right? And then what about the other colors of the visible spectrum? Because when white light comes in, it will be having the colors of the rainbow. It will be, that is the visible spectrum. And then the other colors will be absorbed. That's why we don't see them. They will be absorbed. Do you get it? All right, let's check on question number 3. This is the diagram. Okay, this is our mirror. Our surface is the mirror. Then we've got an incident ray. This is an incoming ray. It is incoming because it is coming to the surface. And then when the incident ray strikes the surface here, there is a reflective ray. This is the outgoing ray. Outgoing ray. Okay. This is the one that gets into our eyes. And then we'll see different colors. That's why we are seeing different objects in our classroom as we are talking. All right? Because when light enters our eyes, the brain interprets them in different light. Okay, remember the light that is coming in, then we'll see different colors. Okay, reflected ray is the ray that is reflected from the reflective surface. And then this is the normal here. And then let's check the right angle. This is the right angle here. Okay, between the incident ray and the reflective ray. Who got everything correct? Great. 8. Got everything correct. I can see some of you totalized. That's very good. And then those who didn't totalize, don't worry. Listen to the lesson. You will get it next time. All right. Let's move on to terminology. Remember, terminology is very important. Grade 8. We are going to define the terms that we'll be learning about in our lesson. And some of these terms, you are going to come across them in the examinations. Okay. Then you'll be able to define the terms And from now, from grade 8 up to grade 12, we will be defining terms. So pay particular attention so that you comprehend them. I want you to understand all these terms. All right, we've got the incident ray. This is the light ray that strikes the surface of an object. And we also call it the incoming ray because this is the ray that is coming into the surface. All right. And then perpendicular. When we're talking about perpendicular, we're talking about a right angle relative to another line on surface. Okay, for example, let's say this is the surface. Then this pen will be perpendicular to the surface. Then it forms a what? A right angle. Do you get it? That is perpendicular. And then normal. This is a line drawn at right angles to the surface of an object. That is the normal. For example, we were talking about the incident ray that is coming into the surface, then the reflective ray that is outgoing, and then in the center there we talked about the imaginary line, which is the normal. And then from the incident ray to the reflective ray, we get how many degrees? 90 degrees. Okay, let's move on. Then the reflected ray. This is the ray that is reflected from the reflective surface. All right. The incident ray is the incoming ray. For example, white light comes in, all right, and then it strikes the surface. And then the reflected ray is outgoing. This is the light that gets into our eyes. This is the light that gives us color, all right. If white light strikes a green leaf, what's going to happen? All the other colors of the visible spectrum are going to be absorbed by the green leaf. But the green light is going to be reflected to our eyes. Then we'll see it as color green because the mind will have interpreted it as green. Are we together? Good. Let's move on. Then we've got the tangent. This is the straight line that does not cross a curve, but only touches the curve at a single point. This is a tangent. We're going to see this a lot in our diagrams as we move on with the lesson. And then we've got retina. This is a layer of light-sensitive cells at the back of the eye. And then what about an impulse? This is the message that travels along a nerve. This is an impulse. And then what about converge? When we're talking about converge, we are talking about coming together. That is converging. That is to converge. Okay. And then what about refraction? This is the ability of a wave to change direction or bend when it passes from one medium such as air to another such as glass. This is refraction. All right. Do you understand it, grade 8? If, for example, we've got white light coming in and then we've got a glass prism here, all right? Remember, light travels through transparent substances or transparent objects. Light can travel through a transparent glass, all right? Therefore, we've got a glass prism here, and then light comes in, white light comes in and strikes the surface. Then what happens to the white light? It bends, it changes direction. That's when we see the colors of the visible spectrum, okay, because of refraction. Refraction means what? Refraction means bending. All right, good. Let's move on. And then we've got convex. When we're talking about convex, we are talking about the what? The outward curve that is convex. What about concave? We are talking about the inward curve. I think you have come across this in different lenses. For example, if you check your friend who's putting on spectacles, you will see the shape of the lenses. Okay. Some of them are outward curve and some are inward curve. depending on what is the purpose of the glasses, because some of them correct eyesight, okay, and some of them enlarge things. For example, when we are using a microscope, it enlarges tiny things, tiny particles, then we can see them, all right? And then seeing light. Light of different frequencies passes through the cornea because it is transparent, and then it also enters the eye through the pupil and travels to the retina. Let's look at an eye. We've got an eye here. We've got the cornea there. Then light is coming in. It will go in and then it will go to the retina. All right. And then let's check this picture here, the cross-section of a human eye. Look at the picture. In the eye, in the back of our eyes, you will see that the picture or the object that you are seeing, it is upside down. And then you can see this candle here, but check the picture that is there in the eye, but it changes. For example, if you remember the pinhole camera that we studied it in the past, it will show you the object in a different direction. It will be upside down, all right? For example, at this candle, it is right up, okay? And then look at this one here. It looks upside down. This is what happens in our eyes. All right, let's move on. Specialized receptor cells in the retinas, in the eye's retina, are stimulated by specific frequencies, or we can say colors. All right, these are specialized receptor cells in the eye's retina. Okay, let's look at this picture. This is very interesting. We've got the sun there as the source of light, all right? And then it is striking an object here. Then some of the colors of the visible spectrum are being absorbed, but some light gets into our eyes. That's how we see what? That's how we see color. Are we together? If there is no light that is coming into our eyes, we cannot see color. For example, if you close your eyes now, you won't see anything. All right? You won't see anything because there is no light that is getting into your eyes. You only see black. All right? And then we've got a good picture here of an eye, which you can play around with. Okay? Then you understand better. The light energy that forms an image on the retina is converted to electrical nerve impulses. These impulses travel through the optic nerve to the brain, which interprets the impulses and tells us what we are seeing. That's why in the classroom we are seeing different objects and different colors. It is because of this process. Okay. We only see this because light enters our eyes. Just imagine at night when it is pitch black, when it is dark. For example, these days we've got load shedding. At times it will be very dark. You can't see anything in the house. Why? Because no light is getting into your eyes. But once you switch on a torch, a light, or even a candle, that's when you can see different objects. Why? Because there is light that is entering your eyes. Then you'll be able to see and identify different objects. Okay, good. All right. The light energy that forms an image on the retina is converted to electrical nerve impulses. These impulses travel through the what? The optic nerve to the brain, which interprets the impulses and tells us what we are seeing. For example, let's see here this diagram. This is a very nice diagram. We've got the source of light there, which is the sun. And then you can see a flower there. You can see the colors pink, green. We're seeing those colors. Why? Because light enters our eyes. And then the other colors of the visible spectrum are being absorbed, and only these can be reflected to our eyes. Then light enters our eyes, and then we're able to identify these colors. Okay, the brain interprets what it is seeing. Okay, it interprets it. Then we can see green and pink, all right, because of the light that would have entered our eyes. And then what about the other colors? Because we know when we're talking about white light, we're talking about the visible spectrum. We're talking about the colors of the rainbow. Therefore, the other colors would have been absorbed. Only the ones that are being reflected to our eyes are the ones that we're going to see. These are the ones that enters the eye. Okay, the light enters the eye, and then the mind interprets it. Then we'll see color. Hope you understand this process. All right, let's move on. If you're not following, make sure you ask questions. We've got an amazing team behind the scenes who are going to give you the answers. Okay, so ask in question, you'll be answered on 079 578 2908. Okay, if all the colors of the light are absorbed by a surface and no light reflects to the eye, the brain interprets the absence of light as black. Because no light is entering our eyes, then the brain will interpret it as black because no light is entering the eye, and you will see the object as black. That's why when you look around in our classroom, you can see different colors, okay, because of the light that is entering our eyes. If all the colors of the visible spectrum are being absorbed at a certain surface, then we'll see it as black. And then when we are seeing different colors, it shows that the light that is entering our eyes is the one that is being reflected. This is the reflective ray. Are we together? Good. Let's move on. White light. This is the colors of the rainbow. This is the visible spectrum when we're talking about white light. Okay. It is coming into a surface. This is the incident ray. It is the incoming ray. Then when it gets into a surface, then we've got a reflective ray, the one that will enter our eyes. It will be reflected from the surface. Then we'll see color. But if all the colors of the rainbow are being absorbed at a certain surface, then we'll see black. Why? Because no light is entering our eyes. Are we together with 8? Good. Let's look at this learner. This learner is looking at the surface, a black surface. Is there a reflective ray there? No. Why are we saying so? Because no light is entering her eyes. Therefore, the surface is black. Okay? The surface is black because no light is entering her eyes. No light is being reflected to her eyes. Okay? All the colors of the visible spectrum will be absorbed by a black surface. Right? Why objects appear to have a certain color? Think about a yellow sunflower. Why do you think the sunflower petals appear to be yellow? This is the sunflower. These are the yellow petals. White light from the sun shines on the petals of a sunflower. The petals absorb all the colors of the visible spectrum except yellow, which can be reflected. All right? When we say all the colors of the visible spectrum are being absorbed, and then only yellow is being reflected, this is the outgoing ray. This is the reflective ray. This is the ray that will enter our eyes. This is the light that is going to enter our eyes. Remember, if an eye enters the eyes, if the light enters the eyes, what's going to happen? We're going to see color of that surface. If it's a yellow surface, then we'll see yellow. That's why we are seeing yellow petals. All right, let's move on. Grade 8. Since only yellow light will reflect to the eye and all the other colors are absorbed, only yellow light will reach the eye's retina. All right, let's see. White light is coming in. This is the incident ray. Remember our diagram, incident ray? This is the incoming ray. This is the incoming light. Then it will strike a surface, and then some of the visible spectrum will be absorbed. Some of the rainbow colors are going to be absorbed, and only the one that is being reflected is going to enter our eye. And we only see color when white light enters our eyes, when the reflective light enters our eye. In this case, it is yellow. Only yellow is reflected, and the other colors of the visible spectrum are absorbed. Okay. Therefore, the brain is going to interpret the color yellow from this information. Okay. Then we're going to have our first activity. This is activity 1, grade 8. Question number 1 says, where does light enter the eye? Question number 2, where does the image form in the eye? 3, explain why the image that forms on our retina is not a true image of what is in front of us. Remember how you see the image that is in the retina and what we see, that the image that is in front of you. All right, we are going to write this activity. I'll give you 4 minutes to answer the activity. grade 8, you must be done writing the activity. Let's check the activity together. But remember to shoot us a photo and send us to 079 578 2908. Would love to see what you have written. Question number 1 says, where does light enter the eye? Where does light enter the eye? All right, we've got our answer there. And then where does the image form in the eye? Where does the image form in the eye? On the retina at the back of the eye. And how would the image be? You remember how the image looks like. And then explain why the image that forms on our retina is not a true image of what is in front of us. It is because the images formed on our retina are upside down, right? When it gets to the brain, it is corrected right up, okay? When it is in the retina, it looks funny. Then when you are looking at it, you see it as upright, okay? Let's move on. Then we're going to refraction of light. You learn that light travels from one transparent material to another. It refracts, that is, it bends. All right. How does it bend? For example, if white light is coming in and striking a transparent glass prism, what is going to happen? The white light will strike the transparent glass prism, then it will refract, it will bend. All right, then we'll see the colors of the visible spectrum. Then different wavelengths of light will reflect. Okay, different wavelengths of light will refract by different amounts. This explains why the glass prism disperses white light into the colors of the rainbow. It disperses the colors of the rainbow. Different colors of light will refract with different angles. All right, we've got a very interesting picture there. This is white light coming in, all right, is an incident ray because it is incoming. Then it strikes a glass prism. Then when it strikes it, it gets in. Then it changes direction. That is, it bends, all right? And then it disperses the colors of the rainbow. Okay, we can see the colors of the rainbow here, right? But when it was incoming, it was white light, all right? And then light enters the glass at an angle to the normal and refracted towards the normal. On the second surface of the glass, the light is refracted again, but the normal of the second side is not parallel to the normal of the first surface. This is why light changes direction. Light changes direction, remember. That's why it changes direction completely. Light travels from glass to air and is therefore refracted away from the normal. All right. All right. White light travels through different medium. All right. Here it is traveling through the air and then it strikes a glass prism. This is a glass, okay? And then what happens to the white light? It changes direction. It bends. It refracts, all right? It refracts here. You can see it changes direction and then it will be dispersed, okay, into the colors of the visible spectrum or the colors of the rainbow, okay? And then when we're talking about the incoming ray, then the normal, which forms 90 degrees, and then the outgoing ray. This is the incoming ray. This is the incident ray. Remember, we're talking about the incident ray, all right? And then this will be the imaginary line. This will be our normal, all right? Then white light gets strikes a surface, which is glass. Remember, light can travel through transparent objects. It can travel through glass. That's why we're in the classroom here. When you look outside, you can see trees, you can see birds. It is because light, it travels through glasses. It travels through transparent substances. Okay, that's why you can see people walking outside. It is because light can travel through transparent objects. And then we've got the incident ray, which is incoming to the surface. For example, the surface here is a glass. And then we've got the normal, okay? And then we also have the reflective ray. This is the light that comes into our eyes, then we'll see color, okay? And then if you check the angle that makes up 90 degrees of the normal, the incident ray, and the angle of the reflected ray to the normal, then it will be 90 degrees. And then when light travels from air to glass, it reflects towards the normal. In the case of a curved surface, the normal will be perpendicular to the tangent on the surface. The parallel light rays enter and leave the lens. They refract to eventually focus at a specific point. Remember when we say it refracts, okay? When we say it refracts, we mean it changes direction, it bends, right? For example, the parallel light rays enter and leave the lens and they refract to a final point or eventually focus at a specific point. For example, these are the parallel light rays that are going to the what? To the lens, okay? And then what happens is they enter the lens. Remember, the lens is transparent. They refract, they change direction. For example, this one, it bends, okay? It bends, it changes direction. This is the normal. Then it bends, it changes direction to a point. And then here, this is the normal, it bends and changes direction to a point. All right. That's why we've got concave lenses and convex lenses. You remember those? Good. The rays are focused on a specific point because the lens is convex. In other words, it curves outwards. Okay, it curves outwards. This is the convex lens here. All right. But look at the incident rays going in and look how they refract to a point. When we say refract, you understand the meaning of refract, grade 8. Is it? Good. If you understand. Those who don't understand, don't worry. When we are talking about refracting, we are talking about the light rays that are going into the glass and then they bend, they change direction. All right? That is refracting. And then they refract to a certain point. All right? And remember the lens, we use them to correct eyesight and some of them to make images look huge. They look bigger, all right? For example, if you're using a microscope, you can see enlarged images. Even if they are very tiny, they are very minute, but we can see them through a microscope because the lens enlarges images, all right? And then it also depends on the shape. And then there are other people who put on spectacles. And then those spectacles, some of them are convex and some of them have concave lens, depending on what they are correcting. All right. Some correct eyesight and some of them enlarges images. Okay. This is very interesting, grade 8, isn't it? Good. Among other things, lenses are used in practice to focus or bend light, to enlarge images or to correct eyesight. We've got different types of lenses here. Lenses are used in the following instrument. We've got different instruments that use different lenses. We've got the cameras, we've got the microscope, we've got the stethoscope, we've got the spectacles. All these use different lenses. And then now we are going to write an activity, grade 8. Our activity is very short. What is refraction? And then 2, what are the two conditions for the refraction of light? I will only give you 3 minutes to answer the questions. 3 minutes to Miss Dagna. You must be done grade 8 answering activity 2. Let's check the activity together. But before we do that, make sure you take a photo. You send us through WhatsApp on 079 578 2908. Question number 1 says, what is refraction? How can you answer this question? We are talking about refraction. Remember what we said. We said if for refraction to take place, it has to strike a what? A transparent medium. All right. For example, when it strikes a what? A glass prism, then it changes direction, it bends, all right? And then it disperses the colors of the visible spectrum. All right, in short, we can say it is bending of light in a transparent medium. All right, that is refraction. And what are the two conditions for the refraction of light? What are the two conditions? Light must travel through a transparent medium with a different optical density and must enter the medium at an angle. Those are the two conditions. All right. Who totalized grade 8? Most of you totalized. That's very good. Those who didn't totalize, don't worry. You listen, you start what we've done, then you'll get it correct the next time. All right. Okay. Then our summary now. Let's summarize everything that we did. If there's something that you didn't understand, make sure you send a WhatsApp and ask. We've got an amazing team behind the scenes who are going to answer you. All right. Summary. Objects around us reflect or radiate light with different frequencies that enter the eye. Remember, we only see the different objects or different colors when light enters our eyes. For example, let's say white light is coming in, then it strikes the surface, and then the other colors of the visible spectrum will be absorbed, and then the one that is reflected to our eyes, the light that enters our eyes, that's what we're going to see. That's what the brain is going to interpret, right? And then specialized receptor cells in the eye's retina react to specific frequencies of colors, right? For example, we've got a candle here. And then how is it going to be interpreted in our eyes? Okay, we're going to see it upside down like this. It will be upside down, but when we see it, we will see it like this. Okay, for example, remember the pin-out camera? This is what is happening. And then in the eye, light energy is converted to electrical nerve impulses. And then impulses travel to the brain, and the brain interprets them as what we see. The brain will interpret them as what we see. For example, we've got the source of light there, which is the sun, and then white light strikes a surface, and then we see that surface as pink and green. Why? Remember, white light, it will be the colors of the visible spectrum. Okay, and then those other colors are going to be absorbed. We only see pink and green because this is the light that will enter our eyes. Then the brain is going to interpret it as pink and green. Okay, let's move on. Light can be refracted by transparent substances. What do we mean when we say light can be refracted by transparent substances? When we say light can be refracted, we are meaning that when light strikes a transparent medium or substance, light is going to be refracted. It is going to bend, all right? Then it will disperse the colors of the rainbow. Okay. When light travels from air to another transparent medium, the light changes direction towards the normal in that medium. When light leaves the transparent medium, it changes direction away from the normal. For example, let's look at these two diagrams here. We've got parallel lines, this one and this one. Okay. This is white light coming in, and then as it enters the transparent medium, which is the lens in this case, light bends, it refracts. Okay, it refracts to a point. Okay, then it will disperse the visible spectrum. And then here we've got a glass. We've got the incident ray, the incoming ray. It strikes the glass, and then what happens? It changes direction, it bends. All right? It bends and then it reflects. Okay. And then a triangular prism can reflect and disperse white light into the colors that are seen in the rainbow. All right. Why are we saying this? This is the white light that is coming in. Do you know what is white light? We'll be talking about white light, white light. Maybe some of you don't understand what white light is. When we're talking about white light, we are talking about the colors of the visible spectrum. We are talking about the colors of the rainbow. All right. The white light is going to strike a glass prism, this one, and then what will happen to the white light? It will refract. What do I mean by refraction? It bends, it changes direction, it bends, all right? And then as it burns, it disperses into the colors of the rainbow. Here it is dispersed into the colors of the rainbow. Because white light strike a transparent medium, then it burns, then it disperses the colors of the rainbow. Interesting, isn't it? And then a lens can reflect and focus light. And then now it's our WhatsApp questions. I want you to send us WhatsApp questions. Therefore, I'll just give you 2 minutes to send us your WhatsApp questions. Then we'll be answering questions. 2 minutes. Grade 8, there are no WhatsApp questions. Hope you understood everything, which is good. And then now we've got a homework for you. Let's copy the homework. I'll give you 2 minutes to answer, to copy the homework. Then you bring the answers to your class. 2 minutes, grade 8, copy the homework. All right, grade 8, you have copied the homework. Make sure you go and write the homework and bring your book to class. All right, that's very good. And then thank you very much. It's been a pleasure having you. So long for now.